All right. Hello, everyone. Hopefully you can all hear me well. I have a terrible habit of using the wrong microphone, but I think we're all working. It's awesome to be here. I'm really excited about this webinar that we've got going on, Securing the Gateways, Mastering API Security. It's a hot topic. And if you've been in security for a minute, you will know that this has been API security or lack thereof has been the cause for a lot of breaches. You can just ask anyone in Australia who might remember the Optus breach about that. So before we get started, we're still just waiting on our main guest, Tristan here. But before we get started, just some housekeeping, a little bit about this platform that we're using. So you'll notice down the bottom, I see lots of you in the chat. So already that's awesome. Hi everyone. It's great to see you. Great to see you all there. You'll notice a couple of buttons down the bottom. One thing is the chat can get quite noisy. It's about 600 people registered for this webinar. So there's a button down there called questions. So if you want to ask a question to myself or to Tristan throughout the webinar, I recommend you using that and not putting it in the chat, because if you put it in the chat, it might get lost. We'll do our best. To ask everyone about that, but it could get lost. So hopefully, there we are. And I'm just going to invite Tristan to the stage, who will be coming shortly. But whilst we're waiting for him, just a quick note. There will be prizes in this webinar. And how do you win those prizes? By participating in it. Hello, Tristan. Welcome.
Hello, Mackenzie. Well, thank you for having me. Excited to be here today. Hello, everyone in the chat. Looking forward to have your questions.
So one of the downsides of having important people like the CEO on the webinar is that they have calls right up back to back usually. So I knew Tristan had a tight connection,
yeah.
But that doesn't mean that for a moment there I was still panicking, Tristan. But it's all good. All right. So just before we get started, and to give Tristan like a minute just to catch his breath, let me know where you guys are all tuning in from. I see that we already have someone, Milou from Greece. Oh, Japan. Wow, awesome.
Hi, Nobuyuki.
Texas, Netherlands.
Oh, there
Berlin.
are many countries.
Oh, Poland. I can't keep up. South Africa. I heard what? Yeah. Oh, a couple from the Netherlands. Goedemorgen. I'm tuning in from Utrecht in the Netherlands. Goedemorgen. Goedenavond. I'm losing it. It's an afternoon here, not morning. Obviously, my Dutch is not that good. So it's awesome to see where everyone's tuning in from. India, Algeria, Philippines, Tunisia, Zambia, Nepal. Wow. Palestine. Amazing. So good to see everyone. I love the global reach that we can get with this. It's really
it's
cool.
Incredible. We have many nationalities there, many places.
Whereabouts are you tuning in from Tristan? I know, but the guests don't.
Where I am from?
Yeah.
I'm based in Paris, and I spend half of my time in the US mostly. But originally, my family comes from the Netherlands and Greece. I see that we have some Greek people as well.
Oh, wow.
The chat. I saw that. Yeah.
See, I'd say we all speak code. Well,
yeah.
We'll put that to the test. But today you aren't here to talk about, to listen to me, and it's as wonderful it is to see where everyone's from. We're all here to listen to the man Tristan. So we have a presentation from Tristan. Tristan is going to be running through, and then we're going to have an opportunity for questions. So as I said down there, there's a button for questions. If you want to ask a question, Tristan, put it in there. We may not answer it immediately, but I'll try and keep up, and then I'll moderate that. So if you've got a question, that's the best place to put it. So Tristan, what I'm going to do is I'm going to get rid of my screen here, and I'm going to invite you to share your screen.
Okay, sounds good. Can I do that?
Just down the bottom, there should be a button that could say share.
And apparently I can even share a Google document directly, so it looks like it's well done. Excellent.
Oh, it's got here. Need access to the slides.
But I got it. Oh, you don't?
I don't. This is weird. We're troubleshooting as we wait. Could you
Okay.
share your screen? Maybe that's going to be easier.
Yeah, I'm gonna do that. Wait, that would be simpler. Share my screen, and there we go. Do you see my screen?
We see it. It's perfect.
Okay,
Awesome. All right.
excellent.
Over to you, Tristan.
Yeah, thank you, Mackenzie, for having me today. Super excited to talk about how to master the API security processes in the modern web landscape. This is a super exciting topic. I've been working on this topic in the past 3 years with my research team at Escape, and we have some information or some data that is exclusive to research that I will disclose today. So I hope you will like it, and I'm happy to take questions also from the community, because I see we are many people today. Excellent. So this is a webinar between Escape and Git Guardian, and I thank also Git Guardian for having me today. So what are we speaking about today? So in the first part, I want to explain a bit why API security is important and why is it different from regular web security, and why is it a new threat? So APIs are eating the world, and this is important. So I will cover that first, and then we're going to cover two different things. First, I will explain what are APIs vulnerable to, and I will disclose information, lessons that we got at Escape from the trenches, from securing APIs, from testing APIs, from scanning the web for API vulnerabilities. And finally, we'll talk about the best practices, so how to implement API security in practice. And we will cover this from the point of view of the security engineers and also from the point of view of the developers, because everyone has his own task and his own importance in the process of API security. Okay, so let's get started. So part one, why APIs are eating the world. Truth be told, APIs are becoming exponentially used in the web. So more than 70% of developers expect to use and create more APIs next year as compared to this year. So we see that more and more developers are either consuming web APIs or creating web APIs. And even better, more than 40% of large companies expose more than 250 APIs. And when we say large companies, it's not like large tech companies. It's like large companies of all industries, I don't know, supermarkets, grocery stores, fast food chains, fashion industry. Everyone is using and exposing hundreds and hundreds of APIs in the wild internet. So this is a bit crazy if you think about it. The evolution of this attack surface that is new and that is more and more used by companies across all industries. And API security is quite a new field and a new set of skills and a new set of tools that not every company has adopted yet. If we ask companies, we have this data that more than 95% of companies that monitor API security said they suffered an API security incident last year. And more than 91% of APIs expose sensitive data. And if you go ask the security teams, it appears that 86% of security teams do not have a complete inventory of the API their company or their organization expose on the internet. So it's a bit crazy. Most of the security teams, most of the organizations do not even know what they expose on the internet, do not even know what are the APIs that they expose on the internet. And of course, you can't secure what you don't know about. So this is the results. We see many data leaks coming from APIs. And we see data leaks coming from APIs from software companies, from companies that are supposed to be mature from a security point of view. Think about PayPal, Instagram, Uber, LinkedIn. All those companies are supposed to have mature application security programs, and yet they got compromised through their APIs, and millions of records were stolen by the hackers and by the malicious users. So what is specifically interesting here is that most of the compromission, most of the exploitations of APIs came from the very specific API threats and API vulnerabilities. And we'll discuss that later. But all of those data leaks came mostly roughly from the same reasons and for the same vulnerabilities. But why is securing APIs that hard? Why are all those companies having trouble for securing their APIs? So there are three main reasons to that we observed from the industry. The first one, it's hard for the security team to keep up with the large number of exposed APIs. Developers expose many APIs, and at enterprise scale, it's very hard to follow up to keep the pace of the exposition of APIs and the update rate of APIs. The second reason, most critical vulnerabilities in APIs are related to business logic, to access control, to like the custom code and not to like known CVEs. So they cannot be found by traditional security tools that are designed to scan web applications for instance, vulnerable packages. And the third reason, no tool currently helps developers secure their APIs during development. Security intervenes late in the API lifecycle. Generally, most API vulnerabilities are discovered during a pen test or pre-production or production, but in any case, very late in the process. So it's not easy to manage and control the amount of vulnerabilities in APIs. So, I mean, you can like probably discuss that in the chat, but this is probably something that you have experienced if you are working in application security in the enterprise context. So now let's switch to part two, like what exactly are APIs vulnerable to? What are the vulnerabilities that affect APIs? What are the risks on APIs? And in this part, again, I will show results that we did at Escape because we have a research team at Escape of security engineers and security researchers, and they scan the whole internet and they do pen tests and they do automated scanning, and they get results that create statistics and data about what APIs are vulnerable to. So if we take like the results and the categories of vulnerabilities in APIs, so those are issues found in public APIs in the wild internet. The most obvious and the most present issues are protocol related issues. So these are the classic. It's not the most interesting. It's like the lacking headers. It's like the unsafe HTTP, many like misconfigurations. So this is not the most interesting. But what we have next is very interesting. We have many APIs that are vulnerable to denial of service because they don't have implemented proper rate limitation. They do not limit the amount of requests per user or to an authenticated user. And then it gets even worse. Many APIs are vulnerable to information disclosure. They disclose information, internal stack traces, internal code. They disclose sometimes token, sometimes secrets in their error messages when you send a bad request to the API. And this is something that is very present among the public APIs. And then if we go to the tail, we can see that there are also many injections and access control problems. And the thing about these injections and access control problems is that the consequences of those vulnerabilities, if they're exploited, are critical. No SQL injection goes unnoticed. No access control problem leading to sensitive data is like not a critical vulnerability. So those are very critical vulnerabilities, very critical issues that needs to be taken care of. So those are all the issues found in public APIs in the internet. But what if we focus on the most critical risk? Let's take the most critical issues and get the detail. So we have like many timeouts, so denial of services for APIs, and unhandled server error that disclose sensitive information. Those are the most common. But then you have like many interesting vulnerabilities that come into APIs, and you can see there are SQL injections, authentication bypass, file disclosure, no SQL injections, cross-origin request forgeries, BOLA, broken object level access controls, tenant isolation problem, so one user being able to access the data of another user, and even JWT manipulation. So this is when you have a JWT to authenticate your API, and you can manipulate the JWT in order to impersonate any other user. So you can see there are many kind of different APIs vulnerabilities that are specific to APIs, and among them, you have many that are related to business logic and to access control. So for instance, you have public state altering operation. This is when you can run delete, put, patch, and this kind of request without the need for a token. You have authentication bypass. You have BOLAs, tenant isolation, mass assignment. All those vulnerabilities are related to the business logic of APIs, and they are very hard to find with automated techniques. Also important, if we take a look at the OWASP top 10 and the OWASP API top 10, and specifically like focus on what changed between OWASP API top 10 2019 and OWASP API top 10 2023. We can see that in OWASP top 10 2023, there is like the broken object level authorization, broken authentication, broken object property level authorization, broken function level authorization, and unsafe conceptions of API. So you can see that there are many newly introduced or former OS top 10 categories that are related to the business logic and not to basic code smells or code vulnerabilities like injections. We are heading in a world where this is the business logic that creates the most vulnerabilities among APIs, and this is what needs to be taken care of. Third thing that is important in API security, the disclosure of API secrets. So we just released today a report at Escape, and this is very linked to what Git Guardian is doing as an activity, the secret security. We discovered that we scanned the whole internet, basically. We scanned like the 1 million most popular domain names on the internet, and we scanned specifically the front-end JavaScript codes, trying to find secrets that were leaking in the front-end code. And we found about 18,000 secrets in the wild, including many secrets that were highly critical. So you can see there is a QR code here. It can lead you to the report. This is a very interesting study. We detail all the secrets that we found and the categories and the risk and how to avoid this situation happening to you. So secrets are not only a problem for any developer, but are also a big problem in the context of APIs, because if there is a secret that appears on the public internet, it can be used to interact with your API and to access the sensitive data, no matter how many protections layer you put in place. Okay. What about now how to implement properly API security? How do we implement API security? I will cover two things. First on the security side, and then on the development side, the side of the developer. So on the security side, the first step in any API security program is to take back control of the API attack surface as a security professional. You need to have an API inventory. You cannot secure what you don't know about. So you need to know exactly what APIs are exposed in your organizations. So of course, in a startup, it can be achievable quite easily. Like if everything is centralized, it can work. But in a large scale organization, in the enterprise, it is very hard to know exactly what your company, what your organization is exposing on the internet. So the idea of building an API inventory is empowering the security engineers, the security team, to be able to answer these kind of questions. How many APIs does my company expose externally? which of them are critical to the business, meaning like which of them, like if they're cut, we are actually losing money, we are losing business. Which of them manipulate sensitive data, like if this API is compromised, like do I like will be fined for customer like data sensitivity reasons? And do we have any development endpoints exposed to the internet? So this happens very often, that the developers or the companies are exposing development endpoints to the internet, and the development endpoints are not as secured as the production endpoints, and they're like the entry point for a cyber attack or for gaining more information about the API vulnerabilities. And do we have any unnecessarily exposed endpoints? It's roughly the same. It's when you expose endpoints that should be internal, but they're actually accessible in the wild internet. And we have seen that happen many times. So the first step of API security is knowing what are the API you expose on the internet. Second step, like do some API threat modeling. Like before starting to implement all the tooling and everything, try to think, if you were an attacker, how could you use APIs to threaten the business? What would you do first? What is risky? What are the first targets? So think about it. Like what are the sensible points? Do some threat modeling, try to understand and really put like some thoughts into the API security strategy. Talk with the developers. Talk with the developers and try to understand how they build the APIs, how they deploy the APIs, where they deploy it. Like, do you have many cloud environments? Do you have on-prem? Is the network segregated? Try to integrate API security into the whole development process, into the environment where the APIs are executed and built. Raise awareness on the API security risk among the developers. So give examples, and I gave some examples in this presentation, in this webinar today. Give examples of API vulnerabilities. Give examples of like API data leaks that were famous. This will help the developers understand why they would need to take some time to focus on securing their APIs, why implementing the best practices is something very important. And finally, implement the best practices throughout the whole API lifecycle. So in general, and this is what we discussed at the beginning of the webinar, it is very hard to secure APIs before the end, like before the production, like very late in the API lifecycle. You should implement best practices in the whole process. So from like the beginning, the development to the production. There are a few things that you can do in order to kickstart your API security strategy. And I've noted 4 here in this as the first step of any API security strategy. So first one is implement an API gateway. Like implement an API gateway because it will allow you to control which APIs are exposed on the internet, which APIs should be internal, to have some visibility in the API process. It does not protect against API threats and API vulnerabilities, dude. This is a misconception, and most API gateways are not really security tools, but more inventory tools. Implement secret scanning. So you have like an awesome company that is expert in secret scanning, and they are here with us today. Especially on front-end repositories. Especially on front-end repositories, because front-end code has a thing called build systems, and build systems can sometimes pack environment variables and pack secrets into the front-end code, and this front-end code will be accessible in the wild internet. So take care of scanning your front-end repositories for secrets that would be leaking on the internet. Third, very important step, test every API release for OWASP API Top 10 and business logic flows. So find a way to test the business logic of APIs before releasing, because this is really like the major risk that you would have if you have implemented the basic best practices. If possible, do that as early as in the CI/CD. So not all organizations have the same level of maturity here, as like some of them are already in DevSecOps mode, others are in DevOps. Sometimes you have like a local environment that you can use to test the API before deployment. Sometimes it's only pre-prod or staging. So it depends on the maturity level of your organization. But if you can do it as early as possible, this kind of testing, this kind of API security testing, I really encourage you to go that way. And finally, last step, have proper security monitoring for live API traffic. It's really important to understand if people start playing with your APIs with the goal of compromising them, to be able to spot those people, to be able to act, and to be able to block them. So monitoring and live visibility is also something very important for API security. Okay. Actually, yeah, just so I know, are there any questions in the... I don't see any question in the chat.
We have a few that have coming through, but
yeah,
I think
okay,
we can wait till the we can probably wait till the
end to ask
to the
the
end and then
question?
get them all together.
Okay,
Yeah.
excellent. Let's do that. So know that we did for the security side, API security from the security practitioner side. Let's do API security from the developer side. And as a developer, of course, you have like objectives about productivity. You need to build something. So security is always something that can slow down the development process. But still, there are some good practices that will not impact your productivity, that will not take you much time, I promise, but that can help a lot with improving the security and the reliability of your APIs. The first thing as a developer that really helps with API security, it's always define and validate user input. It avoids many risks. A common example are XSS vulnerabilities, cross-site request forgery, server-side request forgery. Many of those vulnerabilities can be avoided if you really validate the user input. And I have seen very dirty vulnerabilities in the wild from applications where the user input was not really validated, and it allowed us to get internal like Google Cloud Compute tokens, internal AWS tokens, to even set a foot on the internal like cloud network of the companies. So all of that because a developer did not validate the user input during the build process. Second thing that you can do is beware of front-end build systems like Webpack. I'm saying it again, but I've seen too many companies like have all their secrets like on front-end code, like inside of the JavaScript, because like front-end build system like Webpack, they tend to package many secrets and private environment variables in the front-end code. So use Git Guardian and beware of the front-end build systems. And third important step is to use secure libraries in your API backend code. So for instance, we have like for specifically on the topic of GraphQL, but you have many other libraries for REST APIs and for various frameworks. But at Escape, we've created a middleware called GraphQL Armor, and it implements by default in one line of code in your backend a series of a dozen best practices for the security of your GraphQL API. So this is in the context of the GraphQL API, but of course you have the same for REST, you have the same for various frameworks and API frameworks. Okay, so wrapping that up, how to avoid 90% of API security problems. On the security side, build an inventory. Take back control of the API attack surface. Know your API attack surface and control it. Do API threat modeling. Think about how our API is putting your company at risk. talk with the developers, exchange with them, like share information about how they build and deploy APIs, and also raise awareness among the developers about the critical API security risk and also the past like critical API security breaches. And finally, implement best practices for API security all throughout the API lifecycle, from development to production. If you do that, you're already avoiding 90% of API security problems. On the developer side, validate user input. Beware of build systems because you don't know what data they take and what data they expose on the internet. And use secure libraries and security middlewares. Do not try to build everything by hand when there is a secure solution or a secure library that exists already. So to finish a bit about what we're doing at Escape, we tried to find a way to provide API security that would cover those 90% of the needs. And that's why we created a platform that implements the detection and the building of the automated API inventory. So the detection of exposed applications, including shadow API, zombie API, so API that are not in the API gateway. And we provide security engineer with a fully automated inventory of all the APIs they expose online. We also have created like a module to perform OWASP API item test testing and business logic security testing. So this is a nice piece of technology. We have put a lot of research in it to be able to find data breaches and to find business logic flows in APIs. And finally, we have dedicated that to integration in the CI/CD, so to integrate API security and API security testing and remediation directly in the development process. To explain a bit how we do that, we can correlate the results of external scans. We connect with the developer tools. We connect with API gateways and also with like on-prem instances of APIs. And we use this with an in-house semantic API exploration engine, which is able to understand the business logic API of APIs. We're able to provide alerting, remediations, and the CI/CD testing, of course, of APIs in a fully automated way and developer-friendly way. Okay, that is the end of the presentation. I think there are some questions, so happy to answer them.
Yeah, for sure. That's really interesting, and I have some questions myself as well. But we'll let some other people go first. But we have one here from Arnold. It says that, is there a way to automatically create an API inventory as I build my app? And what should the key features of an API inventory?
Yeah. So an API inventory in the generic sense is like an inventory of the APIs of multiple applications. So it's like a full company inventory of all the APIs from all the applications developed by a company. It's quite different if you want to build an API inventory for a single application. Then you're mostly referring to API documentation, which is the Swagger or OpenAPI file. And if you use a modern API framework, like the modern PHP, modern Node.js, modern API frameworks, they have plugins or middlewares to automatically generate this API documentation using the code, so using the source of trust, the ground truth of the API. And using those kind of modern frameworks is a very good idea and a very good solution for being sure of what you expose on the internet and for having an inventory of all the API routes from a single application. But if you are in an enterprise context, you have many, many applications that are developed by many different frameworks, and some of them are legacy. So you cannot very easily build an API inventory. And this is why we built a system to create this inventory in-house at Escape that will scan all the attack surface of a company using its domain names. and that will use many heuristics, like read the front-end code, try to understand what is the business logic behind the API to create an API inventory that handles many different applications at the same time.
That's great. Here's one here that I can answer myself. It says, as API keys are exposed by mistake, what are some available resources to know when they are exposed? I can answer this because
did you ask this question, or
I did not ask this question. I did not. But one such
Yeah.
resource pays my bill, so I'm going to mention them. But
Yeah.
this webinar is from GitGuardian. So GitGuardian is a tool that can detect secrets. We focus on source code, so then we can detect them throughout the entire life cycle. So there's tools for developers for Git hooks called GG Shield. You can find that on GitHub, or you can go to GitGuardian and sign up to the enterprise platform. But yes, there are resources out there too. And it's an interesting topic too, because I like the way the question was framed, because, almost nobody purposely leaks API keys, right? Most people know not to leak an API key, but it happens from mistake. And the most common way that it happens is in the Git history. And then that source code, even though it's not visible, it's still there in the history, and it becomes leaked. But anyway, I thought I'll throw that up in there, because then I can answer that one too.
Yeah.
Here's another interesting one. As a developer advocate, how should I advise the devs to focus on external or internal APIs first? After all, more modern devs working on internal stuff and creating microservices.
Yeah. Of course. So this is an interesting question, because most of the critical API vulnerabilities I have seen are caused by bad input handling between microservices. So it's basically like the API exposed on the internet like transfers the request to an internal microservice, and you can manipulate the request to like find a security flaw inside of the internal microservice. So both microservices vulnerabilities and security and publicly exposed APIs are important from a security point of view. What I really advise is, first, everything that is directly exposed to the internet must be validated. So the user input must be validated for everything that is directly exposed to the internet at first. And then for each microservice, try to be as conservative in what you accept as possible. So try to implement also input validation and try to avoid exposing the internal microservices to the external world. So I would say start with what's exposed directly on the internet, but keep in mind that also the internal microservices can be exploited, because you never know. Some people mind to find a way to pass through the external service and try to attack the internal microservice.
That's great. We have another one here. It may have already been answered. You just have to let me know. But how should I map API discovery to my app API owners?
Yeah. But this is a very, very good question and a complicated topic. So we at Escape, I can speak about my own experience here. We have a whole research team that works specifically on the topic of mapping external APIs with the repository, the internal repository of the company. Because when you are like in an enterprise context and you have like 250 APIs exposed on the internet, and you have like 3 internal GitLab enterprise instances and 1 GitHub enterprise that are deployed inside of the company, it's super hard to actually match what's external and what's internal. So this is a research topic that we have, and the way we do it is we try to detect the API routes that are coded at the code level inside of the repositories, and we try to match them from the exposed API routes. So this allows us to create like matching between what's exposed and what's internal. But this is really a research topic that we implemented in the Escape platform. I am not aware of any open source tool that allows to do that in an automated way.
Now, I have a question myself.
Yeah.
Now I'm gonna be selfish, but I'm the host, so I can do that. I can ask questions.
Mhm.
But one of the things that's interesting on Escape is that you specifically talk about identifying business logic flaws. Now,
Yes.
business logic flaws are really difficult to be able to discover
Yep.
because it's hard to automate something. The obvious example that comes up is you've got a bank and you're sending someone
Yeah.
$10. Well, what happens if you send someone negative $10?
Yep.
Or the more recent, a real example was in Coinbase. You could basically change your Ethereum or Dogecoin into Bitcoin via their API because they didn't have logic checking that you owned that asset.
Yeah.
So well, I'm curious, how can you then identify business logic vulnerabilities? Because it's a really difficult one because it's hard to know what's meant to be there and what's
Yep.
not.
Yep. So the short answer is we used AA, machine learning. So before it was called AA actually, because we started working on this research before there was like ChatGPT and OpenAI and everything. But basically, we used machine learning techniques to try to understand the semantics between an API. So basically, even if there is no documentation, just you give us a list of routes and we can identify, hey, this is a banking API. Hey, this is an healthcare API. Hey, this is like an e-commerce API. Because there are some patterns that you can recognize in all APIs, like some routes, some parameters that have similar names, and you can see that this is a banking API and that this is like specific route that handles payments. So even if they are like written a slightly different way from one company to another, there is like similarities that allows us to understand that in this specific context there is a problem.
Right, right. Yeah, it's really interesting, and it's an interesting use of AA or AI, however you want to call it, because we're entering a world where if statements no longer work, right? I mean, it's the classic thing about security is like if API exposed, send an
It's
alert.
all if statements at the end. Big. It's
Yeah.
like a neural network is like a big matrix
Of
of if statements.
if else statements. Yeah, so I mean, there's been a lot of masquerading AI as if
Yeah.
statement says AI, but we're entering a realm where you almost couldn't create enough if statements, even if you knew what they should
Yeah.
be to identify business logic
Yeah.
vulnerabilities. So
But
it's
this was like I'm glad that you asked this question because this is one of the main reason for me to start Escape. I'm originally machine learning engineers. I work with big matrices of neural network weights, and I was like, like business logic is really like something very hard to test for,
mm,
and this is something as of today only the penetration testers or the security engineers are able to find it. So why don't we try to find it in an automated way? And that was a long journey, and I'm glad that we made it work through machine learning.
yeah, yeah. All right, let's move on to some more attendee questions again. So with API Gateway securing the external, I think access, should
Yes.
devs implement API security on a single microservice, and how to do this without
Yeah.
compromising the
Yeah.
performance?
Yeah. Yeah. This is a great question, and so to answer that, yes, dev should implement API security on a single microservice for multiple reasons. And the first one is that no API gateway uh, has a perfect bulletproof protection for cyber attacks. Um, the best security is security by design. You can put as many web application firewalls, API gateways in front of an API. There will be always a way to bypass it by encoding the attack in a new set of characters and understanding precisely what is blocked and what is not. So API gateways and web application firewalls, because this is roughly the same, they avoid the basic attacks. But a very motivated attacker, he will always find a way. Whereas if you implement API security at the design phase, at the microservice level, and input validation at the microservice level, then you have a protection that is much more robust and that you will be resistant to much more attacks.
Okay, yeah, excellent. Here's another question. And I think, yeah, this one's, I don't think we've touched on this before, but what role does encryption play in API security? And I'm curious about this because, I mean, are we at the point where we use standard encryption across everything? And if, I mean, if you're using HTTP and not HTTPS, then, well, maybe we've got problems. But does encryption still play a role in API security? Or have we kind of solved this for now?
So for me, encryption in API security is more a matter of up-to-date dependencies. So generally, the problems, basically, most people, they do not expose their API in plain HTTP anymore. That doesn't happen. Like nobody, like the first thing that you will, like everybody will ask as a question about security in API security will be, do you have HTTPS? Do you have like encryption? But what can happen, however, is that the library or the package that you're using for encryption is not up to date, and it has a known vulnerability. And this happens very often, and especially for when you're opening an internal API to the external world. If it's a legacy API, it is possible that it was overlooked and the library used for encryption is not up to date and it's vulnerable. So it's more about maintaining the packages up to date and being sure that you do not try to encrypt the API yourself with custom code or old packages.
Okay. Yeah. Awesome. And it is encryption is an interesting topic because we are approaching the world of quantum computing. Thus, we're a far way away, and everyone's talking about quantum safe encryption at the moment. Now, I was under the impression that, when it comes to quantum, I was like, oh, it's all fugazi. These are machines that need to be stored at negative 300 degrees. No one's going to have them in their backyard. But I was also saying the same thing about AI 2 years ago, and then, well, I was proven to be wrong. So I've changed my perspective on such things. But yeah, well, I mean, I'm curious. This is a bit less field. What's your opinion as someone that's working in security, that's kind of at the cutting edge? Do you feel that quantum computing is going to pose a risk to encryption while we're on this topic?
I think like quantum computing and security, like it will mainly cause like a technical debt problem. So there are researchers working on quantum proof cryptography. And as far as I know, they're pretty successful in creating algorithms for encryption of data that are resistant to quantum computers and also to classic, like good old binary-based computers. But no, the problem will be, even if there are those new, like shiny algorithms that are great for protecting your data against foreign states with big quantum computers that are very cold, the problem will be like, what will be the adoption rate? What will be the update rate? Like, how do we change a technology like HTTPS, like SSL TLS, that has been used by everyone since like ages? How do we change that and we modernized all of that suddenly to be quantum proof? So it's more like a technical debt management problem than a pure security problem, I would say.
Right. Yeah. And so many of these things are. It's just going to be interesting as to when it happens, how quickly it happens, and how quickly it's not going to be. It's not going to be your hacking groups. Even it's going to be nation states that will be the first.
Exactly. That would be nation states. So yeah.
We still have time for a couple more questions, and we're getting more and more coming in. So we'll go for a couple more if that's all right. But there's one that I've just missed it. Here we are. How does Escape do API discovery? Does it look at the traffic of the app once it's already deployed? How do you discover those hidden APIs?
I love this question. I mean, it's very technical. It's like an interesting research topic. I love it. So how do we do API discovery? Basically, we have many different techniques, heuristics that we merge to have like something that is even closer to the ground truth. We can do it by looking at a spec, but that's not very interesting because if you have a spec, you know already what is the API. But what we can do is we can build back the specification from reading the code. We can build back the specification from reading the code. We can build back the specification from reading the JavaScript frontend because sometimes they have like inside of it hard-coded the API roots. And we can also connect with the API gateways. So to of course build back the specification. So there are a mix of techniques. We can discover the API routes from the front-end code. We can discover API routes and build back documentation from the back-end code that handles all the routes and the controller. And we can also connect to the API gateways. And we can do it at scale. So for instance, if you have an internal GitLab instance, you can connect Escape to the GitLab instance, and Escape will crawl all the repositories and find all the API routes from all the repositories and match them to the developers that actually built the API.
Excellent. All right, so I think we have time for two more questions. There's another one here I can answer. I'm liking these questions, especially the ones about
I love it. I will let you this one. This is your field of expertise.
This is my field. How do I automate secret scanning, and how often should I run it? Okay, so this is a really good question. So how do you automate it? You can automate it in lots of different ways, but the core place you want to put secret detection is in your external repositories on the server side. So you can detect secrets automatically via a Git hook, for example.
Mm-hmm.
So that's the best place to detect it, and that's before it gets to the server. But you can bypass that, and developers have to configure that themselves. So whilst it's better to detect it earlier, the place you have to have it is on the server side, is on your Git server, so in your version control system. And when it comes to how often you should do it, every single commit. So every single time something comes in, it's automatic, it runs, and it detects secrets. Because what will happen is there'll be a secret in someone's history. They'll be working on a development branch. They would have deleted the secret. It won't be visible during code review, but it's going to be in the history, and it's going to merge into that source code. And then your version control system, your repository, becomes part of your attack surface if there's secrets in there. So you want to do it every single commit. You want to do it on the server side, on your Git server. And then you can also do it in your CI/CD pipelines. You can also do it once you've deployed your package. Like if you're deploying a Docker image, you can scan it afterwards. All of that's extra. The place that you have to have it is on that Git repository. All right, so I'm done answering that one. But I got to take these opportunities to get in my field of expertise whilst I can. Okay, here's an interesting question. So, how should organizations enhance API security to withstand potential threats from content? Oh no, this is we've already answered this one. We're doing another one.
This is SCA. Like software component analysis. Like do software component analysis, and when libraries start implementing content-proof computing, update all your libraries.
So this is the question that I was meaning to answer. It's from the same person, which is how do organizations strike the right balance between seamless API integration and robust security measures, given the evolving web landscapes and the escalating threat of cyber attacks on API vulnerabilities? So this is basically the performance versus security, speed versus security question, right?
Yeah. Again, so this is a never-ending debate, right? So performance and execution speed versus security and versus risk management. So I think it depends on the context, because it's different from a startup or a tech company versus like a large-scale enterprise in another field. If you're a startup and you have the opportunity to create things right from scratch, like from the beginning, then you're in a good situation because you can implement security best practices from the very beginning, and you can be sure to have like maximum execution speed and still get good API security. So you implement the gateway, you implement the monitoring, you implement proper testing and so on. And you can have like a DevSecOps process that is almost fully automated and that mitigate most of the API security risk. You need to have like data protection and sensitive data leaks detection, because this is the main thing that can happen in this kind of company. But apart from that, you're mostly covered. In the context of an enterprise company, it's way more difficult, and it's way more difficult because you need like a global governance strategy. And I would say the right balance would be to have like if you're in an authorized company and you want to have like security measures for all your APIs, and you don't want to stop all developers from the company of pushing new APIs and new versions, what I would advise is do an API inventory and then perform automated external scanning on all the APIs. This way is very low touch for the developers. It has no impact on the productivity, no impact on their processes, but it still gives to the security team view and visibility over the risk, and it will allow them to prioritize what needs to be fixed immediately.
Awesome. That's really interesting, because this is the interesting topic, and I have this discussion with a lot of people, as well as is the correct answer in security is always, everything should be, you should always prioritize security 100%. Everything needs to be secure, but a lot of people fail to realize that actually there is you have to understand there are business considerations.
Yes.
There's complexities in here, and you
Yes.
have to you have to do this.
Yeah.
We're coming to the end. We're coming to the end now, but you'll notice in the polls section, I've just added a poll to let anyone know. Would you like any more information on escape security? And if you click yes to this, then we will, then we'll be able to follow up with additional information from escape. If you click no, nothing will happen, and if you don't answer, nothing will happen either. But so the no is nice. Just there for fun. But if you would like some information from escape about API security, then hit that yes button,
Yes.
and then we can get that out to you. But whilst you're all hitting yes on that poll, Tristan, I want to thank you for coming on the webinar. It's been really insightful. It was a great discussion, and we really hope to have you back on and hear more about what's been happening at Escape further down the line.
Thank you so much, Mackenzie, for having me today. It was super great to share the insight with the community. I see that many people have answered yes. Don't be shy. Like Escape is a community-focused company. We love to talk about technical topics. So feel free to get in touch with us if you are interested into how we discover APIs, how we test APIs, and what are the different open source projects as well that we have at Escape.
Awesome. Thank you, everyone. Thanks, Tristan. Have a good day. Have a good evening to wherever you are in the world. And we'll see you all on the next webinar.